Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Click on that. It'll open a new window. You can type in your question, hit submit, and I'll get to those at the end of the session. If you're watching live on YouTube, just use the live chat function wherever that happens to be on your screen on YouTube, and I'll go through all the comments at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, 8 years at Subaru. So I worked in a dealership. And over time, I guess, just became the diag guy in the shop, right? So I always had the intermittent problems, the drivability problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type problems that would show up in my bay. And before that, a bunch of other miscellaneous wrenching jobs. Spent a little over 25 years under hood experience for me. So our topic today is a hot topic, and I think maybe a little more hot this week than before, but hybrid vehicles, hybrid vehicle operation and testing. So we're going to talk about different functions of the hybrid vehicle that might be a little bit different than what you'd be used to on working on just a regular gasoline engine vehicle, even though hybrid by definition has a gasoline engine in it as well that does multiple functions, as we'll see as we go through. But definitely gets a little bit better gas mileage than a plain Jane engine. So what is a hybrid vehicle anyway? We've got to talk about, well, what is it? So a hybrid combines at least one electric motor with a gasoline engine to move the car. And its system also recaptures energy via regenerative braking. Sometimes the electric motor does all the work, sometimes it's the gas engine, and sometimes they work together, hence that hybrid operation there. And then that's just a picture of a Toyota hybrid system. You can see we have all these different components, which we're going to cover throughout the course. So there's three different main powertrain types you're going to see out there if you see a hybrid vehicle. Most common one is going to be the parallel design. So this would be the original one that you would have seen in like the Prius, and lots of Toyotas use this system. Subaru uses this system. Lots of different manufacturers use this type of system. As I said, it is the most common. So the gas and the electric motors are linked to a common transmission. So here's my electric motor on the right. There's my gas engine, of course, on the left. And then there's a common transmission in there. And they use planetary gear set in order to drive the vehicle down the road. Now, oftentimes, to save space, things like that, on most newer vehicles, many manufacturers have gone to like a CVT transmission in there as well, because it's a little more compact in there. Also, the generator and the motor and all the gear sets and everything is generally grouped into that one transmission assembly. So if I'm going to take it apart, it's going to be the engine, and then it's going to be my whole hybrid powertrain. The rest of it's going to be on this other side here. So you can see we got a generator, we got the gear set, and we got the motor over there. And we'll talk more in detail through those as we go. There's also a series type. So this is less common. The electric motor just drives the vehicle, and that's all it does. It just drives the vehicle. The gas engine, the only time that is used is to charge the battery. So it's like an electric car with a generator that's a motor. So this example is out of a BMW, the i3, and actually the motor in i8 with a range, one of the ones with the range extender, right? So that they have, it's called the range extender package, and it's basically a motor out of one of their motor scooters, and it's attached to the transmission, and then is used to charge the battery only. It's not connected to the drive wheels. It's only used to charge the battery, and then the electric motor drives the drive wheels. So that's the difference on a series engine. Now, one reason this is not that common in use is due to it's a little jarring for the driver. Some people have complained about, because you can just be driving down the road and you step on the accelerator and it'll go, and then all of a sudden, maybe halfway through your acceleration, the engine kicks in. On a coast, maybe the engine kicks in. It doesn't. The engine just turns on when it's needed. So it's not necessarily needed when I'm stepping on the accelerator pedal. Notice how I say accelerator pedal, because it's not the gas pedal. So the accelerator pedal. So it is a little jarring, and some customers don't like that. Some drivers don't like that. So it's not as common out there to see that. And then the newest kid on the block, I guess you could say, is kind of a mixture between a hybrid and an electric vehicle. So it's called the plug-in hybrid. Now, there's a Prius, there's Chrysler has a version of this. Lots of manufacturers have started to come on board with this design. It's gas and electric motors, once again, linked with that common transmission. The hybrid part is pretty much the same. The generator and the motor are generally grouped in that transmission assembly. Again, the factor here is it's a larger battery with a greater range. And the gas engine, most often, is used only under higher load conditions. So they say, like with the Chrysler minivans, Pacifica, sorry. Chrysler Pacifica hybrid. It is, if you're just going around town, dropping the kids off at school, soccer practice, going to grocery shopping or whatever, that engine may never turn on. And you're just using the battery pack to go around town. And then when you get home, you plug it back in. Yeah, that engine may turn on once a week when you're driving out. It just depends on the load and what kind of driving you're doing on the vehicle at that time. So that's kind of why they've gone this way. It's a good kind of middle road transition to maybe like a full electric vehicle down the road as well. So now that we've talked about the different types of drivetrains, let's talk about the different components in here. So the different components we can talk about with this are, of course, the battery cooling system, generator, voltage converter, regenerative braking, and the electric motor itself. So we're going to walk through each of those. Before we do need to make sure we are being safe. This is by no means a comprehensive training class on hybrid vehicles. So it's really more of an overview. You want to be very, very safe with these systems because you can die. It can kill you, right? So very, very high voltage in there. And if you get hit with the wrong type of voltage, it's going to hurt a lot. So in this case, this is safety warning. High voltage fuse provides short circuit protection of the high voltage battery pack. Positive and negative high voltage power cables are connected to the high voltage battery pack, are controlled by 12 volt normally open relays. When the vehicle is shut off, the relays stop electricity flow from leaving the high voltage battery pack. Warning, the high voltage system may remain powered up for up to 10 minutes after the vehicle is shut off or disabled. To prevent serious injury or death from severe burns or electric shock, avoid touching, cutting, or opening any orange high voltage power cable or high voltage component. So if you see orange, you need to be very careful if you're going to go in there. Both positive and negative power cables are insulated from the metal chassis, so there's no possibility of electric shock when touching the metal chassis, so that's good. A ground fault monitor continuously monitors for high voltage leakage to the metal chassis while the vehicle is running. If a malfunction is detected, the hybrid vehicle computer will illuminate the master warning light in the instrument cluster and indicate check hybrid system on the multi-information display. The high voltage battery pack relays will automatically open to stop electricity flow in a collision sufficient to activate the supplemental restraint system or airbags. So lots of safety precautions the manufacturers take. You also want to take some safety precautions too. There's special tools that you want to use. It's like insulated screwdrivers and things like that. Oftentimes they recommend special insulated gloves, aprons. There's special safety stuff, put cones on top of the car and things of that nature. So if you don't have special training on this, you may or may not want to get involved in this. Just saying, you want to be very, very safe if you do. All right, so battery. This is where the high voltage starts anyway. So multiple small low voltage batteries are linked in series to get these battery packs. So we have these modules, these little small batteries linked together and make big battery. Because it's being linked in series, it results in a high DC voltage of 300 to over 400 volts on some vehicles. Depends on how many packs they have in there and how many volts per pack. Usually it's 200, 300, 400, 500 volts DC. And it could be nickel metal hydride or lithium ion batteries, just depending on what the manufacturer uses for their particular formulation in the vehicle. Due to battery operation, charge, discharge, they can generate heat and they need to be cooled. So to maximize their performance and maximize their life, they need to run at a rough temperature range, whatever the manufacturer decides that needs to be. Now there's three modes or three methods that they use to cool the battery packs. In this case, we're seeing passive air cooling right here. So this is basically just a big blower fan. This is on a Prius. Big blower fan that just blows air through passages on the battery, and then the heat exhausts out the other side. So this is just, it's a fan, sucks in cold air from the outside, pushes it through, and it just goes back out. There's also active, I'm sorry, this is active air cooling. Passive air cooling is where I just have some vents open on the vehicle, and it allows ambient air to come in while I'm driving down. Active air cooling is the fan. And then there's also liquid cooling on some vehicles as well. So here's an example of liquid cooling on, say, a Chevy Volt. So as we can see, there's a couple different things. The cooling can cool it, or it can also warm it. Because if you think about, if it's below zero outside, it could be hard for that battery to work in that operation too. If you live in a cold climate, think of how hard it can be to start your car with your regular 12-volt battery. Some really cold days out there. It takes a little while to get things going. So it can either cool the battery or warm the battery, depending. And we can see the schematic here. So we got a 12-volt coolant pump, so it doesn't run off the motor, it just runs off electric. Goes through a 360-volt coolant heater, which runs off of the battery. Goes through the cooling and heating, and then we also have this three-way valve. So if I go one way, I'm going through the radiator, which is a separate radiator from the engine radiator. Air separator also has a surge tank. It can also run through the battery chiller if we need to cool it off. And then also it can just run through the circuit itself and just kind of loop in there if we don't need to cool it off or chill it even further. So there's a max heat, max cold, and temperature regulating. So temperature regulating goes through here, and then max heat and then max cold. You also notice in here 360-volt AC compressor is what they run now on these things. So very high voltage on the AC compressor as well. And then the motors, which we'll see in a minute, run at high voltage as well. So here's the generator. The generator, as we can see, is sandwiched between the engine and the transmission gear set assembly. It's used by the engine to charge the battery. So when the engine is engaged with the generator, it can generate voltage to charge the battery. It also can be run in reverse. The battery runs the electric motor through the planetary gear set, which runs the generator, which then starts the engine. So most times on a hybrid, you won't necessarily find a traditional starter. And this will come into play when we talk about a no start here in a little bit. It's just a different way of thinking about things. So it does output an AC voltage as well. But you say, well, a lot of the car runs on DC, and that's true, but we also have a converter in there. So it's going to have a converter or inverter, depending on what it's doing. It's going to convert the AC to DC, also steps up or down the voltage from 200 volts to 500 volts for the electric motors in the case of the Prius. And it reverses the step up to charge the battery while doing the regenerative braking process. So it can flow both ways. Electricity can go both ways, AC, DC, 200 volts, 500 volts, step up, step down. Runs all of that off of this through the converter. Here's just a schematic of that. Now, also notice there is a regular 12-volt battery in there to run like the HVAC system, the radio, the lights, things like that run off the regular 12-volt battery. There's also an alternator in there. But you'll notice the high voltage here. So we have the high voltage battery pack. There's a fuse in there. The high voltage cables are these. And then number 3 is the normally open relays. So those are the relays I talked about earlier in there that are normally open. So it's only closed when the vehicle is supposed to be operating like that. And then the high voltage computers up here as well. We can see we have high DC voltage, 201.6 volts DC. Goes into the inverter converter. And then you'll also notice on the electric generator and the electric motor, it runs AC 3-phase. So the motor gets 3-phase back and forth through the inverter. Electric generator gets 3-phase back and forth through the inverter converter. And also the AC compressor in this case runs off 201 volts DC. So we have DC, we have AC, and it's very high, both of them. So like I said, just be forewarned. Anything orange, be careful. All right, so there's that AC 3-phase. Now it's regenerative braking we'll talk about. So what that does is it transfers the energy from braking or slowing down the car, as it were, because I don't know if braking is necessarily the right word, uses the electric motor to brake the vehicle. So the motor ends up running in reverse. It's like downshifting and coasting. So if I shift down in the third gear and the vehicle just kind of engine brakes, that sort of idea. So when you step on the brake pedal, it signals the electric motor to run like at a gear, at a lower gear. Motor runs in reverse, ends up charging the battery. When I have to really stop, like quick panic stop, or once I get down to the end of my rolling momentum, a stop sign, something like that, hydraulic brakes are also still used in conjunction with the engine brake. So it uses the engine brake till it gets to a certain point, and then the hydraulic brakes are still there and they still work the same way you would imagine they would. But being able to do that turns that friction, that kinetic energy into electric energy in order to charge that battery. So that's kind of a cool little thing too. And then we get to the electric motor itself. So high AC voltage could be 500 volts or more AC. It's used to drive the wheels. It's also used to charge the battery during regenerative braking, like we just said. And most are a three-phase AC motor in there. So AC is just a little bit better to run for an electric drive motor, I guess. And that's why they do it that way. So it's most of the time you're going to find an AC motor. And I'll tell you, man, electric motors, really, really good on torque. So you don't have to worry about losing any torque with a small displacement engine there. You just, it's torque on demand on those things. So that's not necessarily a bad thing. All right, let's look at a case study that one of our Snap-on guys gave us. This is from Damian Coleman. He works over in our Cork office over in Ireland, and he is the product manager and EBI specialist at Snap-on Diagnostics. So he does a lot of work with the vehicle software and the experience-based information. So that would be kind of like the guided component test stuff as well. So he brought this. They're working on a Prius one day, and the customer complaint was intermittently the vehicle would not enter ready mode. So ready mode is where I'm going to be able to start driving the vehicle. It needs to be ready, otherwise it won't work. Malfunction indicators on the dash. So in the driver information center, it says check hybrid system or what have you. And then they scanned it and they found codes present in two systems. So in the hybrid control module itself, there's a P3000 with battery control system code. And then high voltage battery control module is a P0AFA hybrid battery system voltage. So they wanted to do some inspection. So upon inspection, they found the high voltage system would remain inactive as long as the high voltage contactors, so these things right here, the mean relays, were not being switched on by the high voltage control module. Because remember how we said they're normally open and it wasn't able to control it. So the system has three different of these relays. So number one is for the positive wire. So we see positive off the battery to the inverter. That's just a straight shot across. Number two is a pre-charge contactor. So that's down here. And then number three is a negative side contactor. So that's down there. Now the pre-charge function here, we got this resistor in there. Pre-charge function is to limit the initial supply of current from the high voltage battery to the inverter. So it kind of lessens the shock to the system. It doesn't just open the floodgates right away. It kind of takes a stepped approach. So we're not totally rushing into the inverter, so to speak. And then we have the different sequence that they would operate in. So ready on. So that's in three stages for the ready mode. So stage one, the positive one's on, the middle one's off, and then the ground one's on. In stage two, just the number three is on, and then at stage three, they're all off. High voltage system off is going to be that combination of there. I don't need to bore you with the different combinations of relays, but depending on how the relays are open or closed, it's going to depend on whether or not the vehicle's ready, whether or not the vehicle can move, and so on, and what the charging situation is. So on this vehicle, remember how he said the battery is made up of little batteries tied together. So in this one has 14 14.4 volt blocks. So 14 blocks at 14.4 volts each. And then each block is made of two 7.2 volt cells. So totally, if we add it all up, 201.6 volts DC on this particular vehicle here. So once again, safety first. You want to make sure you disable the system. You want to make sure you're not messing around anywhere where there's high voltage in play without safety equipment, and just make sure you don't get hurt. We don't want anybody to get hurt. So in order to service the system, you want to pull that service plug. So he's got his high voltage voltmeter here, just reading the voltage to make sure if there is high voltage in the system, we don't want to do that. And remember also 10 minutes or more in order for it to be discharged and enough to work on. So pull off the service plug, and then they went into and took a look at the battery. So here's how the battery blocks are laid out in a general drawing of that. So we got the high voltage battery control module right there, which controls the whole show. And then we have the high voltage battery cable. So the orange here, this is on the negative side, and then the positive side would come down. This is the negative cell, and this is the positive cell. And you see how they're tied together here with this battery bus bar. So that gives me positive and negative, so that's my two cells. Each block has a corresponding sensing wire that goes back to the control module as well. So we can sense the voltage and condition of each of these battery blocks as well, which comes in handy in a second, you'll see. So it can read independent voltage and measure as to what's going on with each of those blocks. And if there's a problem, we'll let it stop. So here's another picture as the high voltage control module there. And then the current clamp, there's a current clamp in here as well that measures the current flowing through on the negative side on the negative wire there. We can see the positive side is orange, and then we have orange there. So this is all stuff you got to be very careful around the stuff. You want to make sure it's discharged and safe before we go and work on that. So as I said, each of these is set up with a wire that goes to the module. So that means we have data. So they went in and took a look at the data stream, and you can check individual battery blocks. I'll show you what this looks like in more detail in a little bit when we go live. But you see this battery block here and that battery block there going all kind of up and down and all around, and negative 15 volts to negative 16 volts. So it's reading not good, reading negative 15 to positive 16. So it's going on either side of zero. So that's not doesn't make sense. It shouldn't even happen. Very erratic. And then we can see the normal battery blocks as the voltage is going up like that, and they're kind of matching each other. So that's the way they should look with voltage data right there. So obviously there's some issues with these couple of battery blocks there. So what they did is they disassembled the battery blocks, and they found these bus bars, the copper bus bars, and a lot of them were corroded. So however corrosion got in there, but you can see that there's where they kind of cleaned them up there. They got a little toothbrush over there to clean them up, polish them up, and reassembled, reinstalled. And then the block sensing circuits were also inspected and cleaned as well. Went that far, still having a problem. So they came over to the battery control module and found out that there's some green fuzzy stuff on the module there as well. So it looks like we probably got some water intrusion in the whole system there. But there is definite corrosion there. So that's going to cause a problem as well. So they replaced that as well. And then the car worked, car's fired up, and it was fine. So they wanted to verify, though, after you've done all this work and taken things apart and reassembled everything, you want to make sure you return it to the customer in good shape. So they went and did a road test. So this is for just 4 of those battery blocks under hard acceleration. Now this results in a voltage drop in each cell. So there's my hard accel event right there. All 14 blocks should return a similar voltage under all conditions. Full electric mode, hard acceleration, and regenerative braking. They should all mirror each other pretty darn close, because they should all be operating pretty much the same way, because they all have the same basic specifications. Here's another example, all 4 battery or just 4 battery blocks under regen braking. So you can see how the voltage is going up as well. This results in a voltage increase on each block at the end. And then you see we also have 4 different vehicle states that we want to be able to monitor. This is on the driver information display, actually, which is kind of nice because it gives you another piece to the puzzle to go on when it comes to diagnosing a problem. So we have the vehicle off situation where it says nothing's connected. Internal combustion engine operation, you can see the engine is driving the wheels, and it's also driving the electric motor to charge the battery. And then we see on electric only, it's running off the battery right into the electric motor, out of the electric motor into the tires. And then on regenerative braking, you can see it comes off the tires into the motor and then into the battery. So it just kind of shows us which mode the vehicle thinks it's operating in, which can help us in fault finding. And also we want to, when road testing the vehicle, we want to check the condition of the high voltage battery under certain operating conditions, like we said. So they road tested it. During this test, they're looking for a difference of no greater than 0.3 of a volt between any of the battery blocks under a load. So he put up a little spreadsheet here and just wanted to see the difference in voltages between the different blocks under different conditions here. So there's your difference right there. None of them are even close to 0.3 of a volt. Well, maybe I guess the 0.22 is a little close, but we don't see anywhere near 0.3 of a volt there. And then same thing on this case. So this was under regen braking here. And then I also wanted to show the voltage and amperage relationship that you would see with this as well. So the power battery voltage versus the battery current. Remember how I had a current clamp on there? So when voltage goes up, current flow goes down because it's flowing back into the battery. So you end up getting a negative current flow because it's flowing back towards the battery. When we go the other way, when the battery is being discharged, when the voltage is going down, that means the current must flow out of the battery back into the system. So that's where we get that right there. So we can see 98 amps right there, 182 volts. So this is stuff you don't want to mess around with unless you're being really careful or know a little bit better what you're doing. But I just thought it was kind of interesting how we could see the relationship between voltage and amperage as we're just looking at data pits. So that's pretty handy. You can do that with a scan tool. So let's go live and look at a couple different functions that we can talk about with the scan tool. All right, excellent. So first off, I want to pull out of my history here. I'm going to load a 2012 Ford Escape. This one was kind of interesting because I had a buddy who had a starting problem with this Ford Escape. And remember how I said that the starter doesn't have a starter? It's actually started by the electric motor. So if the battery goes dead, the big battery goes dead, or below a certain amount of voltage, vehicle won't start. And you'll think it's a no start problem. You can replace that 12-volt battery all you want under the hood. It's never going to start. It's never going to start the vehicle because of how the vehicle starts. And that's another thing I want to impress on you is if you have a no start on a hybrid, that could be very well be why. You could have a discharged battery, at least a low enough battery, and it's not going to do a darn thing. Working on the 12-volt battery, it's the high volt battery. So in here, I'm going to load this Ford Escape hybrid. Pop in shop key, and I'm going to search for the high voltage battery. Okay, so let's say we want to replace that high voltage battery. Oh, sure, it's all-wheel drive, whatever, doesn't matter. And then we have TSBs. So there's a couple bulletins, I think. Let me see. Yeah, two bulletins. Charging system. So here's the high voltage battery charging process right here. All right. So when full hybrid vehicles, powertrains exhibit a no crank condition, it is important to identify if diagnostic trouble codes are preventing the engine from being cranked and if the high voltage battery must be charged. Discharged high voltage batteries are typically caused by repeated starting attempts or improper long-term vehicle storage. Base engine issues such as fuel or ignition problems can cause crank no start concerns as well, and ultimately a no crank condition because we wear down the battery. If the high voltage battery becomes sufficiently discharged with these two DTCs may be set, resulting in a no crank condition. So there's certain DTCs that'll keep it from starting as well. In order to recover a discharged high voltage battery, dealerships may request a rental charger. So this is a fancy high voltage charger. Let's see. Once confirmed the charger is required, Midtronics will ship a charger directly to the dealer. The dealer will pay a rental fee for shipping charges. There are some that exist out there in the wild too, in like hybrid specialty shops as well. But this is in this case, this particular one's a dealer only, but this is through a TSB, so kind of makes sense. This was interesting though, that I found this. Diagnostic tip, watch this video first. A no start condition on hybrid electric vehicles is frequently mistaken or misdiagnosed as a start stall condition. A hybrid start stall crank no start video should be watched before commencing any repair actions on the vehicle, including further start attempts. Now, valuable information in here. So we actually have a link to it, multimedia. A supplement to the article is available. And I have my fingers crossed right now. It's going to work. It worked last time, but there we go. Excellent. So this is there we go. You're not going to be able to hear it, but for mistaken hybrid start stall condition, I'm going to make that a little bit bigger there. There we go. So it talks about how it uses planetary gear sets, etc., and it starts the vehicle using that with the planetary gear sets. We also have the gas engine there, of course. And then what they do to show you is they disable the engine, pull a wire off, and then try to start it. You'll see that it tries to start around like 1200 RPM or so, and it actually makes a noise like it's trying to start, and then it stops. So this could be misdiagnosed as a start stall situation. So you want to be able to go in there, you check some data on the scan tool and see, is the battery discharged? And if it is, we have to get some special tools in order to fix that as well. Sorry, my volume's not on my tool, but you'd be able to see that in there. It's a very helpful video for that type of situation. I think it's kind of neat how manufacturers are now adding like videos and audio to their TSVs as well. And of course, you do have access to that right through Mitchell or Shopkey in order to get to those types of things when the manufacturers include them. So I think that's kind of cool as well. So that's just one example on a Ford Escape. Next one, I'm going to go into the Big Bad Prius here. And first thing I wanted to note is in guided component tests. So if you have a Snap-on scan tool with a scope meter, you have guided component test database in there as well. So we're going to load this Toyota Prius. And you'll notice on some vehicles, we have a hybrid electronics section, not just the gas engine. We also have the hybrid electronics section as well. And you'll notice there's quite a few things in here. So for example, high voltage warning. Prius V hybrid system contains 201 volt high voltage system with a sealed nickel metal hydride battery, strong internal alkali solution of potassium hydroxide. System is capable of producing a maximum of 650 volts DC. Don't touch it. You do not touch it. By the way, latex and nitrile gloves are not approved to service any HV system component. You want to use special hybrid service safety gloves. And they actually give you a part number you can order through SPX or OTC, as well as Snap-on has them as well. I got some examples on the auxiliary battery and the hybrid vehicle service plug as well. So in order to safely perform diagnosis, inspection, or service of high voltage components on a hybrid vehicle high voltage system must be disabled. In addition, manufacturer requires factory technicians to successfully complete factory technical training to perform service on a hybrid system. All high voltage warning harness connectors are orange. High voltage components are identified as either high voltage or orange wire harness connections. When servicing a hybrid vehicle, remove metal objects that will conduct electricity, such as a pocket screwdriver, mechanical pencil, or a ruler that may drop accidentally and cause a short circuit. So nothing metal in your pockets. I'd probably get rid of the keys too. And then carry the removed service plug in your pocket to prevent others from reinstalling it while you're servicing the vehicle. I guess that's a case of the warning is written because of experience, I guess, for that. And it is in the right front of the trunk area. We'll need to remove the rear deck floor box to access it. Also disconnect the 12-volt battery negative terminal first as well. So it gives you a lot of information in there as to how to do that safely. And then there's some service bulletins that list down here if you want more information as well. All right, and then if we go into just the regular engine, because it is a hybrid, it does have a regular gas engine in there. So things like camshaft phasers, cam and crank sensors, electric water pump. Remember how we said it's got an electric water pump instead of a engine-driven water pump? Just saves on parasitic losses. And well, we got a big area of voltage in there we can use to run the water pump as well. So that's kind of a sample of what we got in there. And then also in the scanner, we can go in and take a look at what's going on in the scanner with our Toyota. So let's see, we're going to go down to our hybrid vehicle area. And we're going to go to the hybrid vehicle ECU right here. And you see we got a few things. We got actuator tests. So I can go into the actuator test. We can do inspection modes, water pump for the electric water pump on or off. Drive the battery cooling fan. Remember how we said that the Prius battery has a cooling fan in there. We can turn it on, turn it off for diagnostic purposes, right? I want to see, is that blower fan working? I can turn it on and off with here. Also, a high voltage cranking request can turn on or off as well. So we can test the cranking. And then we also have data display. So this is where we can actually look at the battery data on this vehicle like we were talking about before. So we can actually look at this. It's of course, demo vehicle, so it's not the actual data on a real car, but it gives you your different status of charges, and then each of those battery blocks, right? So even numbers are on the left, odd numbers are on the right, and we can see how they line up. There's number 2, there's number 1, there's my different voltages, and then the internal resistance as well. So it can do a check with resistance in there and see if it's got high resistance. and so on, battery low, battery high, etc. So there's a lot of data that can be had on these vehicles for diagnostic purposes. And I think that's pretty handy when it comes to wanting to diagnose those battery blocks like they did before. I think that's kind of cool. And the last one I'll leave you with, last vehicle, is going to be our plug-in hybrid. So the Pacifica, 2018 Pacifica plug-in. So we'll go in here and I'll show you a couple functions. Oh, there's my secure gateway coming through. Okay. Unlock. Okay, there we go. So if we go down to the hybrid control processor, right there, we can go in and check a few things in here. So I got to pick the one off the meter. There's miscellaneous functions in here, such as high temperature coolant fill, auxiliary pump, low temperature coolant fill, active pump, low temperature coolant fill, passive pump, and then reset clutch capacities, reset high voltage cable open DTC. So there might be a certain DTC that you would have for a high voltage cable open as a function in there to reset it. There's this resolver offset learn. So this is kind of interesting. So this procedure clears the resolver offset for both motors, allowing the hybrid control processor to relearn the resolver offset in the next ignition cycle. This is for the motors, the electric motors there. So it's going to go through and reset, and I think it actually gets stuck here in the simulator. So I'm going to cancel out of that. So a lot of things to do with the coolant, etc. There's other functional tests in here, like the chiller shutoff valve, front refrigerant shutoff valve. A lot of coolant system things are controlled through here. Fan duty, electric transmission, oil pump speed as well in there. So lots of information to be had on these hybrid vehicles. So you can rest assured if you are going to go work on those, you do have plenty of options, plenty of information, plenty of data available to help you in your diagnostic workflow when it comes to hybrid vehicles. All right, so that's my time for this evening. Let's talk about next week. Next week, all new. Start all new classes again next week. So next week, it's kind of funny how we're doing this. We're waiting this long to do it, but it's going to be basic electronics class. Because I've talked to a few of our reps and they're like, hey, can we do like just a basic electronics class so we can get a good grounding on, what all is voltage, what is amperage, what are a few basic tests that we can do, voltage drop, things like that. So we're going to go back to basics on a basic electronic class. And then in 2 weeks, there will be an electric vehicles class. So we're going to go from hybrids, relearn our basic electronics, and then we're going to go into full-on electric vehicles too, which share an awful lot with the hybrid. So hopefully you can join me for those. And like I said, the next 5 weeks are going to be all new material again. So if you want to go to snapon.com/OT, you can actually see the class schedule is there. Plus you can sign up for the class on Zoom, 6 and 9 Eastern every Tuesday. We also stream the early session, 6 p.m. Eastern session to YouTube. We go to youtube.com/Snap-on Diagnostics. If you're on YouTube or watching this on YouTube, please make sure you subscribe to the channel and ring that little bell there in order to get notified anytime we do go live or post new stuff. Also, give this video a like if you would, because that helps us out as well. If you want to see any of our past topics for these live streams, we've been doing this for over a year and a half now. There's 37 different episodes of content. So anything from ADAS, data bus testing. We did a component testing series over the summer, HVAC, pressure transducers, and then our hybrid class is up there as well. So if we go to youtube.com, once again, Snap-on Diagnostics is the username, and you can check that out as well. So now we're going to get to questions, but before I do, I want to make sure I mention my buddy Al. So Al also does diagnostics training. He does diagnostic training on specific scan tools 3 nights a week. So on Mondays it's Apollo, Wednesday it's Zeus, and Thursday it's Triton. 2 classes a night, same time as me. So 5 and 8 Central, 6 and 9 Eastern. Go to snapon.com/OT to register. You can go on the right-hand side under Al's head, and you can see the where you would click to register for each of the individual classes. The first hour on all the classes are going to be covering pretty much the same thing, just on each individual tool. So let's get your Wi-Fi set up. Let's set you up with a free Snap-on Cloud account, so you can actually share your files with your customers, pre and post scans, things like that. And then he's going to walk through code to completion, total workflow on Fast Track Intelligent Diagnostics. How does this help me as a technician diagnose cars faster and easier. So that's the first hour. Then on Wednesday and Thursday, after a 5-minute break, since the Zeus and Triton also have scope and meter functions, he goes through all the scope and meter functions on the tools, some real world examples, things of that nature. So it is a very thorough class. Al goes through everything from soup to nuts and still has more left over that he probably could cover. But he does a really good job of covering most of the good stuff that you really need to know. Al's been with us for over 30 years, so definitely a wealth of Snap-on scan tool knowledge there. So definitely check him out if you have not already, or if you need a refresher course, always good for that too. All right, let's see. We got one question on Zoom. Maybe check hybrid vehicle with scanner while in charging. Yes. So if you're on the scanner mode, it's not, you don't really have to worry about high voltage or anything like that using the scanner. It's when you get into the meter and the scope functions. But yeah, you can definitely use the scanner while it's in charging mode for sure. You can road test it with it. That way you can collect the data as well. And you can see how the battery's doing while it's charging. You can check the percent of charge and everything. Looks like we went on multiple screens on YouTube today. Let's see. Mike's Automotive Diagnostics. Welcome. You checked in right before we started. Thank you for that. I hope you're enjoying your grilled burgers. Said you might have a little bit of time for that. Abel, welcome. Thanks for joining. Nick, welcome as always. Good to see you over there from the UK. It's pretty late there. 23 Chicharo, I guess. Thanks for joining me. Thanks for watching. Let's see. Carlos, greetings from Winchester, Virginia. Thanks for checking in. Let's see. Raymond from Yonkers, welcome. Thanks for joining us. Mike's Automotive Diagnostics says we use lockout tagout procedures with that. That's definitely a good plan. And he also likes the pocket idea, works good too. So if you can't possibly plug it in because it's in my pocket, then I guess it's okay as well. So that's kind of like lockout tagout. And then I Am No Sleep, thanks for joining us as well. Thank you for everybody joining us on YouTube. So definitely appreciate everybody. Oh, El Salvador. Nice. Eficaz Automotriz. Greetings from El Salvador. Thanks for watching. Thanks for joining. Definitely appreciate everybody checking in from around the world too. It's pretty cool. Pretty cool. Thomas, thanks for checking in. Let's see. Andrew says, can we see on the scanner not getting a charge? I'm gonna say yes, but I'm gonna hedge it with it depends on the manufacturer as to what data they'll give you. So like we saw on the Prius, tons of data there. Definitely would be able to tell if the thing was charging down to the battery block. You could see the amount of voltage in there and how it was doing. Some other manufacturers might not be as forthcoming with their data. So with that, like I said, your mileage may vary depending on what the manufacturer is. But yeah, I would say by and large, you would have good luck seeing whether or not it was getting the charge or not. So hope that answers your question there. Doug from Canada. Thank you very much, Doug, joining from Canada on Zoom there. So it's definitely been a bit of a wild week. So thanks everybody for joining. Oh, Nick's got a question on YouTube. Health check vehicle battery hybrid. When should you carry out a vehicle health check on the vehicle? I'd say anytime you're doing regular maintenance on a vehicle, maybe 60,000 mile service, something like that. I'd say probably be a good idea. You could do the that data PID readout. You could print that out and use that as kind of a health check too. That's kind of a neat thing. I just kind of thought of that. I could print out my screen and see, okay, here's the state of charge of your battery. That's kind of a cool thing. Some of them even have a PID where state of charge or how much is worn out. So lots of different ideas we could do with that. So I think that's a very good question, Nick. Thank you. All right, with that, I think we got everybody cleared out. So I'd like to thank everybody. Appreciate you for taking time out of your busy schedule. Let's come spend a little bit of time with us. Hopefully learn a few little tips and tricks about hybrid vehicles. Definitely be safe when you're doing so. But definitely thank you for spending your time, taking it with us. And with that, enjoy the rest of your week. Enjoy your weekend and take care.